Chapter 4, Differential Equation. Okay, previously we have learned about the first order differential equation. So there are 4 simple applications for the first order differential equation, which is applied in the real life, which is population growth. Okay, we have population growth, radioactive decay, Newton's law of cooling, mixture problem. And today we will look at the population growth. So the formula in population growth is n equal to a multiplied with e power of kt. So in population growth, the problem occurs when the various fields like the economic growth, bacterial growth, and the population growth. So if nt, so let's say we have a function of nt, okay, which is the nt is the population of the given specific with the time, okay, then we use dn over dt. So dn over dt is the rate of the change of population of that species per unit time. So is proportional to n. So the formula for population growth can be derived. Okay, so can be derived like that. Okay, so we have dn over dt is equal to kn, where our n0 is equal to n0 and k is a constant. So we will have 1 over n. Okay, how we get 1 over n? We just change the position. So n move to the bottom and dt move to the top. Then we will get like this, 1 over n times with dn equal to k times dt. And then we integrate both right and left hand side. We will get integration of 1 over n dn is equal to integration of k dt. Okay, so integration of 1 over n, we will get ln n, and integration of k, we will get kt plus c. And then we come out with n equal to e power of kt times e power of c. So we have learned previously where a is equal to e power of c, so we just replace the value of ec here with a, then at the end we will get our n equal to a e power of kt. So we look at example 1 here. Okay, example 1 where the population of Z plus is growing exponentially. Okay, so population of Z plus growing exponentially. So at the beginning, there was 70 zebras, and 5 years there were 2,100 zebras. So how long will it take for the population of the zebras to reach 305,000? So first of all, we try to prove by using the formula that we have proved previously. Okay, let me do one by one. So dn is equal to kn. So in order to solve this equation, you need to integrate dn and kn first. So change the position, then we will get 1 over n is equal to dn. Okay, we integrate both sides. Then we need to integrate, okay, sorry, this is dn over dt. So 1 over integration of k dt. Okay, then from here, we will get ln n at our left hand side and kt plus c at our right hand side. So we want to cancel our ln, we need to multiply by exponential both sides, right and left hand side. We multiply by exponential in order to make our ln cancel. So e power of kt times e power of c, then e power of c we change with a, then we will get n is equal to a e power of kt. Okay, so from here we know our t equal to 0. Okay, why our t equal to 0? Because they have words beginning here. So means starting at t equal to 0, we have n. Okay, n is our zebra. Population is equal to 70. Okay, and then our 5 year. Okay, we solve for this one first. So when our n is 70, and our t is 0, e power of 0. Okay, so from here we will get our a is equal to 70. Okay, because e power of 0 is equal to 1. Okay, then from here we look at our second question, second statement, which is at 5 years. So when our t is equal to 5 and n is equal to 2100. So zebra becomes 2100 when our t is equal to 5. So when we replace in the formula of n equal to a e power of kt, we will get 2100 is equal to 70, where we have found previously our a is equal to 70. We just replace a equal to 70 times e power of k. Our t now is 5 times with k. Okay, so now we want to find the value of k. What? Okay, so e power of 5k is equal to 2100 over 70. Okay, so from here we want to make our e cancel. So what we need to do is we need to multiply all here by ln. Okay, so what happen next? It will become like ln power of e times power of 5k is equal to ln in bracket 2100 over 70. Okay, actually modulus here. Okay, so we can cancel ln and e. We can move like this. 5k is equal to ln 3. Okay, so we can find the value of k is equal to 0.6802. So after we get the value of k, we can replace back at our formula previously, which is n equal to 70 e power of our k 0.6802. Okay, so from here we also given next when t is equal to what? Okay, sorry, when t is equal to what? Okay, the question want to find the long time. So when t is equal to what? Which is our n equal to 3500. Okay, so at here we just replace our n equal to 350,000 is equal to 70. Okay, 70 times dengan e power of 0.6802k. Okay, then from here we need to solve the value of our t. Sorry, this one is t. Okay, because we already the value of k. Sorry, we just replace here. Okay, this one is our okay, this is our t. So t. Okay, so from here we will get t is equal to ln 305,000 over 70, okay, over 0.6802. There we will get our t is equal to 12.5209 years. Okay, so this is our answer. Okay, let we look at example 1b. The rate of growth of the population of a one pine is proportion to the current population. So if the town of the population, so we have town of population, so this is our n. Okay, in 2000. Okay, so in 2000 population. Okay, so this is for 2000 and another one is for 50,000. We have population 50,000 in 2013. Okay, so we assume starting 2000 is our initial. So t equal to 0 at 2000, where our n is equal to 35,000. And after 13 years, when t is equal to 30, our 2013, and our n is equal to 50,000. Okay, so the step is simple like this previous example. So when we have dn, dn over dt, then is equal to kn. This is the basic that you need to do previously before you start your calculation. So integration of dn over n is equal to integration of k dt, where you will get ln n is equal to kt plus dengan c, then exponential. So n t is equal to ae power of kt. So you need to do this first before you proceed to answer the question. So at t is equal to 0, then your n is equal to 35,000. So you will get 35,000 is equal to ae power of 0. Okay, so a is equal to 35,000 because e power of 0 is equal to 1. Okay, so after that we can do our next step. Okay, our next calculation is at t equal to 2013, where our t is equal to 30 years from 2000, then our n becomes 50,000. Okay, so from here, from the formula that we have found previously, which is nt equal to ae power of kt, so from here we will get 50,000 is equal to 35,000 times e power of kt. So k times with 13. So we will get our k is equal to ln modulus 50,000 over 35,000, over 5. Over 13. Okay, so we will get our k is equal to 0.0274. Okay, so from here we want to find the population at year 2016. So how to get at year 2016 is t equal to 16. So at t equal to 16, we want to find the value of n is equal to what? So based on the formula that we have highlighted previously, the formula for n is equal to a, which is our a 35,000 that we have found previously, times with e power of k 0.0274, then our t is equal to 16. Then we calculate, we will get our n is equal to 55,258. Okay, let me look at next example. Example 2. Okay, example 2, we want to find the number of bacteria in a culture was initially 110 strands. And after 2 hours, the number of bacteria were found 405 strands. So find the equation of the population at any time. So here we want to find the formula first. So like previous example, we need to solve for dn over dt is equal to kn. Okay, so when we simplify, we will get dn over n is equal to integration of k dt. So ln n is equal to KT plus C, then N is equal to AE power of KT. So at T is equal to 0. So at T is equal to 0. Okay. Initially, the words here initially means our T is equal to 0. Then our N is equal to 110. So just replace the value of N 110 here is equal to AE power of KT. So AE power of K, our T is 0. So we will get is equal to A. So our N is equal to 110. Okay, so we already given in the question when our T is equal to 2. Okay, when our T is equal to 2, then our N becomes 405. Okay, so what we will get? 405 is equal to 110 e power of 2t. So, no, 2k. Okay, so we want to find the value of k here. So, k is equal to ln modulus 405 over 100 over 2. Okay, we will get the value of k here equal to 0.6517. So n, the basic formula for this equation is n equal to 110 times e power of 0.6517 t. Okay, so this is the formula for the this situation. Okay, where when you have time, you need to identify or forecast for the number of bacteria for the future. We use this formula. Okay, next we look at the example 2. Okay, how long it will take? Okay, this is the same question from previous. How long? Okay, so when we ask the question asked to find how long, so we want to know the times with the population ants become 100,000. So previously we have the formula which is n equal to 110 e power of 0.0 0.65 0.6517 t. So when our n become 100,000, so it will become 110 e power of 0.6517 t. Okay, then we will get our e power of 0.6517 t is equal to 100,000 divided by 100. Okay, then our t will become ln 100,000 divided by 110 over 0.6517. Then we will get our t is equal to 10.45 hours. Okay, so this is the times to make the bacteria becomes 100,000 strand. Okay, so for the exercise, you can try to solve it first. Okay, next we look at radioactive decay. So for radioactive decay, we have the formula of P equal to A times e power of negative KT. So what is radioactive decay? Radioactive decay is the spontaneously emission radiation. So if you learn physics, you will learn more about radioactive decay. So if PT is the mass remaining from the initial mass of substance after time t, then the total number of radioactive substance decay is proportional to the number of radioactive substance present. So the formula for the radioactive decay can be derived as below. Will dP over dt is equal to negative Kp. Why negative? Because it have differentiation. It will have the decreasing number when the radioactive was decay. So at P0 we make it equal to P0 and K is a constant. Okay, the first step from the formula here, dP over dt equal to negative Kp. So first we need to change the situation. Okay, change the dt move to the up and our P move to the bottom. So it will become like 1 over P dP is equal to negative Kt. Then we integrate both sides, we will get integration of 1 over P dP is equal to negative K dt. So when we integrate this one, we will get ln P equal to negative Kt plus C, and then we want to cancel ln, so we need to multiply both sides with exponential. Then our P becomes P equal to e power of negative Kt plus C. Then e power of C is equal to A. Then we will get our P is equal to A e power of negative Kt. Okay, let me try to solve number 1. So the original amount of the radioactive substance is 120 gram. Okay, then after 10 days, the amount of substance is 100 gram. So we want to find its life. Okay, its life. Okay, so we need to show first. Okay, first step, you need to show the formula of dP. dP over dt is equal to negative Kp. Okay, so integration of 1 over P dP is equal to integration of negative Kt. Okay, so ln P is equal to negative Kt. Sorry, this is dt. Negative Kt plus C. Okay, then we want to cancel the ln is we become e power of ln P equal to e power of negative Kt plus C. Then we will get P is equal to A e power of negative Kt, where our e power of C is equal to A. Okay, so for the first question, we are given, okay, at P0 when our T is equal to 0, because of original amount here means our T is equal to 0, then our P is equal to 120. Okay, so we just replace the value of P equal to 120 here, while our T is equal to 0. Then we will get our A is equal to 120. Then we will get the new formula for PT, which is PT equal to 120 times e power of negative Kt. Okay, so from here, we also given P10. Okay, after 10 days, we will get the amount of substance is 100. Okay, so from the formula, okay, from this formula, we just replace. Okay, now our T is equal to 10. Okay, P10. So 100. P is equal to 100 when our T is equal to 10. So 100 e power of negative K times with 10. Okay, we want to find the value of K. So e power of negative 10K equal to 100 over 120. So we will get K is equal to ln 100 over 120 over negative 10. Then we will get our K is equal to 0.0182. then we just replace into the formula of PT is equal to 120 e power of negative 0.0182 t. Okay, so this is our new formula when we get the value of k, which is k is our constant, and we also identify our a here. Okay, and the next question, we want to find the half-life. So what means by half-life? Okay, half-life means T is equal to what? Okay, so half-life means our P is equal to, okay, no, sorry, P is equal to, okay, we know here the total is 120. Okay, total here is 120. Original amount of radioactive is 120. So half mean 1/2 times 120, then is equal to 60 here. So this is our new value of P. Okay, means our P is equal to 60. Then our A we have found previously 120 e power of negative. K also we have found previously 0.0182 t. Okay, so we solve for the value of t here. Then we will get our t is equal to ln modulus 60/120 over negative 0.0182. Then we solve, we will get our t is equal to 38.09 days. Why this? Because it's already given to us in the question by day. Okay, next we look at the example 2. A radioactive isotope has an initial mass. So initial means our T is equal to 0. Then our mass is equal to, okay, this is P. P equal to 100. Okay, so let the first one we need to integrate first. Our dP over dt is equal to negative Kp. So we integrate both sides. dP over P is equal to integration of negative K dt. Then from here we will get ln P is equal to negative Kt plus C. Okay, then we will get our P is equal to e power of negative Kt plus C, or P is equal to AE power of negative Kt. So this is the basic formula for radioactive decay. So the first statement we already given, when T is equal to 0, then our P becomes 100. So 100 is equal to AE power of negative K times 0. So from here we will get our A is equal to 100. So substitute back into the formula, we will get P is equal to 100 e power of negative Kt. Okay, for the second step, look at the information given to us, okay, which is 2 years later. So mean our T is equal to 2 now. Okay, only 75. Okay, only 75 means our P becomes 75 now. Okay, of the isotope remains. Okay, so we want to find the value of K here. So we just replace our P is equal to 75. This is from the formula of, based on this formula. Okay, so our P now becomes 75 is equal to our A that we have found previously, 100 e power of negative K, then our T is equal to 2. Okay, so that we will get our K is equal to ln 75 over 1000, okay, over negative 2. Okay, so from here we will get our K is equal to 0.1438. Okay, so we just replace the value of K that we have found previously into the equation of P equal to AE power of negative Kt, where our K now is equal to 0.1438. Okay, so we want to find the half-life. Okay, so what means by half-life? Okay, half-life here means P is equal to what? Okay, what time? We want to know our radioactive decay become half. So 100 over 2 is equal to 50. So we substitute in the formula that we have highlighted previously. When our P is equal to 50 and our A is equal to 100, our K is equal to 0.1438. We want to find the value of T here. So the value of T here is equal to ln modulus 50 over 100 over negative 0.1438. Then we solve, we will get T is equal to 4.82 years. So this is the answer to make our radioactive become half-life, which is 50. Okay, let we look at the next example. So for the next example, the initial mass of the vibranium substance is 100. So after 5 days, the substance decay by 30. What is the half-life of the substance? So as usual, we need to integrate both sides first. dP over dt is equal to negative Kp. So integration of dP over dP over P is equal to integration of negative Kt K dt. So we will get ln P is equal to negative Kt plus C. And when we make e power of ln P equal to e power of negative Kt plus C, and we solve, we will get P equal to a e power of negative Kt when our A equal to e power of C. Okay, so the first step, we already given initial, means T is equal to 0. So when our T equal to 0, our P becomes 100. So we just replace the value of P here is equal to 100. A E times T equal to 0. So we will get here our P is equal to 100. Okay, we just substitute back into the equation above. We will get P now is equal to 100 e power of negative Kt. Then we already given also when our T is equal to 5 and the decay is become 30%. Okay, decay 60%. What means by decay 30%? Okay, it means that our P now become 30%. So if we have 100% minus with 30%, so what left? Only 70. Okay, only 70 our P. So next example, 70 is equal to 100 e power of negative K times with 5. So from here we will get the value of K, which is equal to ln of 70 over 100 over negative 5. Okay, then we solve, we will get our K is equal to 0.07133. Okay, then we substitute back into our equation, which is P equal to 100 e power of negative 0.07133 K. Okay, so from here, next we want to find the half-life of the substance. So we know at the initial our P is equal to 100. Then half means our P now become 100 divided by 2. Then we will get 50 here. Okay, so from here we can find our T is equal to what? Okay, so T is equal to what when our P is equal to 30. Okay, so make our P now is equal to 50, 100 e power of negative K, which is already found previously, 0.07133 K. Sorry. Okay, then K here. Okay, then we want to find the value of K. Not K, there is T here. So we can find the value of t, which is t equal to ln 50 over 100 over negative 0 over negative 0.07133. Okay, so then we will get our t is equal to 9.72 years, because we use years here. This, we want to find years. Okay, so next for the exercise, you can do by your own, and then we will discuss later. Thank you.